We're going to start talking about polynomials. So we're going to move away from all of our linear and exponential situations, and we're going to talk about many different pieces of a polynomial. Now, a polynomial is simply an expression where the exponents are 0 or higher. So, and we have different levels of polynomials. So if we have only one piece or one term, that is called a monomial. If we have 2, it's a binomial. 3 is a trinomial. And then anything more than 3 is called simply a polynomial, meaning many. So I want to talk to you about the different parts of a polynomial. So we have things that are called terms. The terms are simply the different pieces of a polynomial. And as I said earlier, it needs to be an exponent of 0 or higher. Okay, we're not going to have any negative exponents in this. We're not going to have any radicals. We're not going to have any exponents in a denominator. Okay, it's just the different parts. When we were in 6th grade and we started talking about integer rules and we were circling the sign in front of the number, those were our terms. So if you look at this first one, I've circled, this one happens to have 6 different terms because it has 6 different parts. That being said, we have what we call the degree of a polynomial. The degree of the polynomial is the highest exponent in that particular polynomial. So here you can see these are all out of order. That's not how we usually write them. We usually write them in descending, meaning largest to smallest exponent. And whatever your degree of your polynomial is your highest exponent. So if you look here, our highest exponent appears to be a 5 on this one. And then again, when we write them, we need to make sure that they are in descending order, meaning highest exponent to lowest exponent. So this one is going to be 3x to the 5th. Make sure you keep your signs. Plus 2x to the 4th. And then we have plus x to the 3rd. We have plus 2x squared. We have plus 7x, and then we have minus 16. Some other pieces of information that I want you to make sure that you're aware of. We have also things called a leading term. So our leading term is going to be 3x to the 5th. Let me zoom out so we can write this down. Right, so we have leading term, and that is simply the term with the highest exponent. Okay, so in this case, the 3x to the 5th is the leading term. And then we also have what we call a leading coefficient. And that is the coefficient of the leading term. So in this case, it would be just 3. So we could say leading term, 3x to the 5th, leading coefficient is going to be 3. And that's basically polynomials. So if we look at number 2 here, this just has one term. The degree is, again, the highest exponent. Well, we only have one exponent, so 4. And in descending order is just 3y to the 4th. We could add that 3y to the 4th is the leading term, and the leading coefficient would be 3. And I know it doesn't ask for that, but I want you to make sure you understand that vocabulary. Here we have 1, 2, 3 terms. If I wrote them in order, it would be 7a to the 4th plus a squared minus 6. Now, And so our degree would be 4 because that's our highest exponent. I do want to draw your attention to this negative 16 and this negative 6. Those are our constants. Those don't have a variable. So technically it's a, we could say it's negative 16x to the 0 because we know anything to the 0 power is 1. So these are our constants. They're still terms, but remember those are called constants. If we wanted to know the leading term here, it would be 7a to the 4th, and the leading coefficient would be 7. So one of the things we can do with polynomials is we can add and subtract them. Guys, this is just a new fancy way of saying collect like terms. That's all we're doing here. So collect like terms. So we can put a's with a's. So we have 12a, negative 3b, positive 5b, plus 2b. And it's that simple. Now, when you do write it, you want to make sure that it is in that descending order. Now, these are both with exponents of 1, so then we need to make sure that it's in alpha order. So we have 4a squared, and we have a negative 6a squared. So we're going to say negative 2a squared. And then ab is going to come before b squared. Think about alphabetical order, right? So negative ab and a positive, negative 5ab and a positive 10ab, so plus 5ab, negative 6b squared, and a negative 6b squared is a negative 12b squared. So make sure that you are trying to write it in that, that order. So just so you're aware, on number 4, we have 2 terms. The leading term is 12a, the leading coefficient is 12, and the degree is simply 1. Here we have 3 terms. We have a leading term of negative 2a squared. We have a leading coefficient of negative 2, and we have a degree of 2. Now, I want you to look at number 6 very carefully, 6 and 7. They're very similar to what we just did, but instead of a plus in the middle, there's a minus. So remember, that is a negative 1, and we're going to have to distribute that. So we have h squared plus 6h plus 9 minus 25 plus 10h minus h. So now we can collect like terms. We only have one h squared, so it's going to go first. H squared, h, h, h. So 6 and 10 is 16 minus 1 is a positive 15h. 9 minus 25 is a negative 16. So now we have 3 terms to the degree of 2. The leading term is h squared, and the leading coefficient is 1. Same thing here, distribute all the way through. That's the biggest mistake we make. Negative 4x cubed minus 6x squared plus 3x minus 1. I'm actually going to go ahead and write this underneath because I've run out of room here. So a negative 8x cubed minus 4x squared plus 2x minus 3. So I have negative 12x to the 3rd power minus 10x squared plus 5x minus 4. So again, we have 4 terms. The degree is 3. The leading term is a negative 12x cubed, and the leading coefficient is negative 12. We can do the same thing with shapes. So perimeter, again, it's simply collecting like terms. 5a, and then we have plus 5b. Constants always go at the end, minus 5. Be careful here. Remember that you have 2y's plus 3, and 2x minus 2's. So x and x is 2x, y and y, 2y, and 2y is plus 4y. And then I have a negative 2, and a negative 2 is a negative 4, 3 and 3 is 6, so that is plus 2. K comes before m, so 3k plus 2k is 5k, 4m and 5m is 9m, and then 4 minus 3 is plus 1. So what I'm going to ask you to do tonight, now that we've talked about all of this different vocabulary, is I am going to ask you to try the back of this, okay? So it's talking about like terms. Can we put them together, yes or no? 5 through 8, is it polynomial or is it a non-polynomial? Meaning that it has individual terms, or remember, it cannot have an x or a variable in the denominator. It can't have a square root. And then name it, right? If it has 2 terms, it's a binomial. 3 is a trinomial. 1 is a monomial. If it has more than that, it's a polynomial. The degree, so remember, degree is the highest exponent. You can also have, actually on this one, this is a little different. So the degree is you're going to add the exponents, right? So here we have 2 and you have 1, so the degree here is 3 because these are monomials. So try that one. That one might be a little bit tricky. And then here we have the degree, meaning what we were talking about, the degree of the whole polynomial. So this is, again, that highest exponent, the leading term, the leading coefficient, and if it is a polynomial, if it's not in descending order, write it that way. So I want to check this classwork, so I would like you to try this whole page tonight, and then tomorrow in class we'll go over it.